Hello, this is second video in the C4 sequence, if you want to call it that. And what we did in the first video, I just put it on the board there, just to remind you of what we did. Essentially what we did is we did partial fractions with two linear fractions on the bottom. We're going to step it up again today. We're going to do it with three linear factors, and I'm going to show you how you would do that. But first of all, I'm going to recap what it looks like. Okay, so I'm going to use an example to show what it looks like, and then actually work out that example. So I'm not just showing you a random example. We'll go through one together. Okay, so what is, well, hopefully you know what partial fraction is. I was about to explain it, but hopefully you know what it is. It saved me a little bit of time. So if you are using the C4 book that we get given, does look again something like that if you're in my class. If you're not, don't worry about it, that's just some paper I was showing you. But this essentially is a little bit more difficult. So what we've got on the top is 2x squared. So this is question 5 for those of you that have the book on exercise 1.1. 2x squared plus 17x plus 21 over x plus 2 x plus 3 and x take 3. And that equals, okay, so obviously we've got three linear factors on the bottom, and when it was two linear factors, we put constant A over the first linear factor, constant B over the second linear factor, and we're going to do the same. We're just going to have another one, constant, we call it C, and do it over the third linear factors, and we're following the same pattern as before. And most of this is following the same pattern as we did for the two partial fractions, because it's the same sort of way of doing it as well, just it looks a little bit more complicated. It's the same method but just a bit more of it. Essentially that's what they are. So if you can, but obviously I wouldn't encourage you to have a go while I'm trying to get through it, because there's some things that I need to highlight really, which I'll become more apparent as we work through. Okay, so that's what you should have. There's something that looks like that, as it might even say express it in that form, so you know there's definitely there should be three fractions, but just by looking at that you should know there should be three fractions. Okay, so what we first need to do, we times this, so we times both sides by x plus 2, x plus 3, x take 3. So basically what this does is get rid of the bottom bit, so we say 2x squared plus 17x plus 21 is equal to A. Now, what we could do is we could put A over x plus 2, and then we could have that A times x plus 2, x take 3, x plus 3 and x take 3. But as the x plus 2's would cancel out, we'd rub that out, so that's what I'm going to do, just to save a bit of space. So it would just become A of x plus 3, x take 3. So basically A is times by what isn't ever on the bottom of here. So A is times by, if you've got x plus 2, it's all of the linear factors that aren't x plus 2 that you times A by, because obviously the x plus 2's would cancel out. Same story with the B, times it by everything but x plus 3. So that's x take 3 and x plus 2. So we could do the same method where we wrote the whole equation B times the whole of the bottom, but the x plus 3's would just cancel out. So we just write all the linear factors that are on the bottom of the first equation, except the one that is below B, because obviously they would cancel out. So it's B times x take 3, and the only other remaining linear factor is x plus 2. And then we go on to C. Again, same sort of thing. C is quite confusing because it looks like a bracket, so I have to do it a bit bigger. So again, we times everything on the bottom by everything here except what's ever on the bottom of C, so that's x take 3. So we times by x plus 2 and x plus 3. So it should be set familiar with that, there's no need to factorise that 2x squared plus 17x plus 21 because we're not going to do anything like that. It's easier just to leave it like that so you can put the x values in when we come to it. So as I said, we're going to be following the same sort of method. Now the only thing to watch out for, well you don't need to watch out for it anyway because you get the same answer. But obviously some of the factors here, so x plus 3 appears in C and x take 3 also appears in B. So whenever you put, say you've got x take 3 when you want to make one of them factors equal to 0, so you say you want to make x plus 3 equal to 0, x would be minus 3, so you put x is minus 3 into each x value you see in there, and it just leaves you with B, because B doesn't have an x plus 3 factor, so none of them are going to be 0, but because A and C have that factor, they're both going to be 0. So it just leaves you with B. So then we just continue to do that until we get A, B and C, and then we put it in this formula. But obviously you put x is it whatever into this as well. Don't forget the left hand side of the board. So I'm just going to, I said that a bit quickly, so essentially what it is you've got each of the factors there, so that's it sort of expanded for you, and you need to make each one of them factors equal to 0. Now obviously x plus 3 occurs in more than one, so you only need to do it for each individual factor. So you need to put, so you've got x plus, the three factors are x plus 2, x plus 3 and x take 3, and you need to make in each of them factors it equal to 0, and then put that x value into all of the x's you see in that equation. So if you understand that, just pause the video now and give yourself a go at it, and we'll go through it. As I said, there's no need to factorise the quadratic there because it's easier just to leave it like that. So I'll just give you a second to pause the video now and have a quick go at that one. Right, so hopefully you've had a go at that one. I'm going to go through it now, and if you've been lazy, you can just copy down the answers. But if you haven't and had a go at it, then you can check if you're right, obviously. Assuming I am, which I don't see why I wouldn't be. Expert guy I am. So obviously the first one we would do is, you could do whichever, doesn't matter what you did. I'm going to try and find B. So the one factor B hasn't got is x plus 3. So that's what I'm going to make equal to 0. And x plus 3 is equal to 0, hence x is minus 3. So put x is minus 3. And what I always do is just before I'm about to start in inputting an x value, I put on the left hand side of the board, just before I do that line of working, what x is equal to. And it becomes apparent when you correspond it with the above equation, and you can see where x is and what you replaced it with, but that just helps me in my mind. So if we do that, so 2x squared, so that's 2 times minus 3 squared, which is 2 times 9, which is 18, but I'm not going to write that in, I'm just writing what with the x equal to minus 3. And obviously what we could do is we could write a brackets minus 3 plus 3, a x take 3, minus 3 take 3, so it'd be a times 0 times minus 6, but anything times 0 is obviously 0, so we don't need to bother with it a. Now as I said, C also has that factor, so we don't have to worry about C, all we have to worry about is B. But obviously if you wanted to be thorough, and I'm assuming you did, you could put x's into all of them on the right hand side, and you would have got A is 0 times minus 6, which is 0, and you would have got C as minus 3 plus 2, which is minus 1. So C times minus 1 times 0, which is 0. So if you got that, you could have done another line of working with just then leaving B in. So B would be minus 3, take 3, which is not 0, it's minus 6, times by minus 3 plus 2, which is minus 1. So obviously that would leave you with, so on the left hand side of the board we said 2 times minus 3 squared, so 2 times 9, 18, 17 times minus 3 plus 21, and that all comes to positive, negative 12, and that's equal to positive 6b. So what we do is divide both sides by 6, so minus 12 over 6 equals b, and that equals minus 2. And what I do there is I've done it on my sheet, is I've highlighted what b is, because obviously we're going to do a bit more working out, so you're going to lose where x is. And if you've just got x's, you might be inclined just to write down x equals this when you're actually being asked to find the partial fraction even. So we've done x equals minus 3, so we've got x plus 3, we made that equal to 0. The next factor that's going along is x take 3, we need to make x take 3 equal to 0. So x take 3 equals 0, add 3 to both sides, that x is 3, and that's what we're going to put in. This is a little bit confusing because it looks like it's quite confusing where I've got these from. So x take 3, I'll just remind you, is actually from the x plus 3, well, bracket, but we need to make that equal to 0, so we took away 3 from both sides, that's why we've got x is minus 3, and x is 3, we got that from, because we said, okay, the next factor along is x take 3, so I'm just doing it along here. You could easily do it along here, but you need to put each one of the factors equal to 0, and then put that x value into the whole equation. So this x equals 3, we said, okay, x take 3 must equal 0, so add 3 to both sides, that gets x equal 3, that's what we're going to put in. So this first part, 2 times 3 squared, obviously it's going to remain the same. 17 times 3, it's going to change from 17 times minus 3, plus 21 equals, now x is 3, so a times 3 plus 3, so a times 6, times 3 take 3, which is 0, so a times 6 times 0, which is going to be 0. Obviously you could write that in again, but I'm just trying to save a bit of space. And then put it into b, so b is 3 take 3, which is 0, so b times 0 times, it doesn't matter what this is, but it's b times 0 times 5, which is 0. So we're just left with c. C times 3 plus 2, c times 5, and c times 6. So c times 5 times 6. Therefore, c equals, 90 equals 30c. Divide both sides by 30, so 90 over 30 equals c, and that equals c equals 3. So just like here, we're sort of arranging it out in the same way. Okay, so we've got b and c there, but we still need a. So what would make a, what would keep a? So the only factor we haven't done is positive 2, x plus 2, and there are two factors that are in b and c. So if we make that equal to 0, we're going to get rid of b and c, and we're just going to be left with a times something equals whatever this left hand side comes to. So x plus 2 must be equal to 0. So if we take away 2 from both sides, it gets x equals something, and x equals 0 take 2, x equals minus 2. So this is what x value is going to be. Now obviously in each of these constants, so x equals something, you could actually do the equation of each factor, and that might actually help you in your mind, but I'm just trying to save a bit of space, and I'm just going to talk, I was talking you through each factor and how we got it, okay? So the next one, x equals minus 2, so 2 times minus 2 squared, plus 17 times minus 2, and obviously you can work this out as you're going along, but it's easier just to put it like this, I think, plus 21, and obviously b and c is going to go because b times minus 2 take 3, so b times minus 5, minus 2 plus 2 is 0, so b times minus 5 times 0, it's going to be 0. It's going to also get rid of c because c has got the factor x plus 2, which is what we made to 0, so c, x, so minus 2 plus 2 is 0, so c times 0 times minus 2 plus 3, which is c times 0 times 1, so that's going to get rid of b and c, so we can get that, and then we're just left with a, so write a in. A is minus 2 plus 3, it's minus 1. Oh, sorry, it's positive 1, for God's sake, I don't know what I was talking about there. And then x take 3, so, sorry, one sec, make sure I've got this right. Yeah, and that, x take 3, so minus 2 take, minus 3 is minus 5. So that gets us 25, oh down, is that right? No, sorry, minus 5 equals minus 5a. Divide both sides by minus 5, it's obviously what it's going to be, it's going to be 1. So minus 5 over minus 5, and a is equal to 1. That's not, it looks like it's done because we can find a, b and c, but it's actually asked us to write it in that format at the top there. So that's what we're still going to do. I'm just going to make sure the camera can still pick it up. Okay, so there we go. So I still have to write it in a, b, c format. So I'll zoom out just a tad. There we go. So we're still going to write it in that format at the bottom there. So we write this part again. Obviously you don't have to, but it's a good idea. 2x squared plus 17x plus 21. See how much easier it is now we didn't factorise it. I could go on about what would happen if we factorised it, but I don't want to confuse anyone, so I'm just going to leave it at that. 2x squared plus 17x plus 21 over x plus 2, x plus 3, and x take 3 equals a over x plus 2. What is a? 1. So a was 1 over x plus 2 plus, oh no, that's right, by the way, I just wrote it wrong on the board, plus, now this is a good mistake actually I made to prove to you. Never put a plus until you know what the coefficient of either a, b or c is. So b is minus 2, so it's actually take. Now you don't need to write b is minus 2, you just need to change the sign in front of b. So take 2 over x plus 3. And what was c? C was 3, so we can go positive 3, so plus 3 over c, which is x take 3. So that's your answer there. So if you got that, you give yourself a good few marks there. So I suppose that would be quite sort of a difficult one to do. Obviously you're going to get harder ones than that, but I think that's quite a difficult one for this triple malarkey anyway. So you can see how we followed the same formula as we did for the double partial fraction, except we just did it for 3, and it made it a little bit more complicated, but we still put as one of the factors equal to 0, went through it, found a and b and the other constant if there was one, which in this case there was. So basically what we did is we got rid of the denominator on the left hand side by timesing both sides by the denominator of the left hand side one. And obviously the one of the factors on each of the constant cancels out because it's a times x plus 2 over x plus 2, and then a still times by x plus 3 and x take 3. So we just cancelled them two factors out, did it for the corresponding for b and c, put x as 0, x plus one of the factors equals 0, worked out what x was, put that in, and then repeated that step for the other two or 3 factors depending on what you're dealing with, and then rewrote the fraction with our new found a, b or c constants or whatever you got. Obviously a, b and c can be different. You could have, as I said, x and q or whatnot, unless it told you to find a, b and c, because obviously you'd lose marks, you know, if you got z was equal to something that a was actually equal to, which just far too confusing. So just use the numbers they've given you, and I prefer to use a, b and c anyway, because anyway that's what the exam board likes to give. So hopefully that's been some help. I think that's quite a good way of remembering it. So just hopefully that's clarified a few things for you, and it's been quite useful. So we'll see you in the next few videos, but hopefully you've learned something from that, and any questions just drop me a comment, and don't forget to like and subscribe.